Hello, we are Regolith Revolution, and my name is Alex.
And I'm Matthew.
We're just going to talk about our design a little bit, and then we're going to talk about some challenges that we expect with our design for our first vlog.
And also we'll talk about our goals for winter break. So first, our design.
Yeah.
We actually changed our initial design. So the thing we kept from our initial design was the Archimedean screw, and that will be used to pick up dirt, soil from the lunar surface and bring it into the device. And then from there, initially we had our cups where we would fill the dirt in at mid-level, but in this new design we put the cups at the bottom, attached to a gear, so we could rotate around the Archimedean screw.
And the reason we want to rotate the cups is because as the dirt gets pulled into the main compartment with the Archimedean screw, it'll get scraped off at a certain height into the cups. So then we'll just rotate the cups with the gears and fill up all 3 cups with just one scraper from the Archimedean screw, bringing in the dirt.
And once we do that, we will close off the hole at the bottom to make it sealed, and then we'll repressurize it so it's at a regular atmospheric pressure.
And heat it.
Yeah, and heat it as well. And the next step will be adding the fertilizer and the seeds, as well as the water. And we will do that by these tubes at the top. And in each one of these tubes, they will be filled with either fertilizer, seeds, or water. And we will be able to individually drop them into each cup by having little holes in the middle section. And when we open those holes, they will drop it into the cup. And we can rotate the cups around the axis so each cup gets fertilizer, water, and the seed. So that's basically it for the design, the new design we have. And now we can talk about some challenges we expect to face.
Yeah. So neither of us are electrical engineers, so we're reaching out to U of I now to get assistance on the electrical engineering aspect of this, because that's something we're not familiar with.
In terms of the design itself, some challenges we'll face are that we have to make sure there are no air leaks in the device, because any air leak will basically make it a vacuum and the seeds will die instantaneously. And also we have to make sure that the Archimedean screw will actually pick up dirt from the lunar surface, and that'll be a major step if we prove that. And also an agricultural challenge would be to create to imitate lunar soil with things on Earth. So
Right.
we'd have to basically make fake moon soil.
Right, we know the composition of moon soil, so we should be able to do that. But we might run into problems while doing that. So for our goals, for near term, we're working on funding and lab space, and we're in contact with the deans of the University of Illinois, and they've already agreed to give us lab space and funding. And then by winter break, we want to have a functional Archimedean screw that can go down, pick up dirt, and then a scraper that'll scrape it into 3 different cups, and we'll have a working gear system to demonstrate the dirt getting scraped into 3 different cups.
And for that goal, we'll probably use 3D printing to print all the parts. And then for our final design, our final engineering design, we will use machine fabricated parts.
Yeah, and then on the agricultural side, by winter break, we hope to be growing plants with fake moon soil mixed with fertilizer to help us decide how much dirt we need, how much fertilizer we need.
Alright.
Yeah.
Thanks for watching Regolith Revolution's first vlog.
Continue to follow Regolith Revolution on our journey to the moon.
Thanks.